Hello and welcome to our presentation. My name is Ryan and this is Jacob. We will be working on our midterm project, presenting our midterm project called the One Langer. And he'll be presenting first.
Yep, for simplicity's sake, Brian's going to handle the clicking. Okay, so a quick overview of what we're going to be talking about today. I'm going to start with the individual part design. There are 16 in total. Just some of the difficulties that we run into that, some of the challenges for each individual part. We're going to discuss the final assembly, constraining it, getting it all proper to look like that nice isometric over there on the top right, importing some of the standard parts from the catalog like the screws, and then we're going to discuss the drafting process that we had to go through to develop the isometric exploded view, and then dimensioning for all the individual parts, like that isometric view in the bottom right. Okay, thank you very much. So this is my first part. This is the base plate. This screws onto the wooden plate that holds the entire assembly. Only interesting thing here would be the hole callouts, which were like M3 countersunk or something like that, as well as a couple of different patterns because there are holes that attach this plate to the wooden plate that I mentioned earlier. There are holes that attach the bearing holder and also the piston brackets, which you'll see coming up here shortly. Thank you very much. So this is the crankshaft bearing holder. Most interesting thing about this particular part is it could have been difficult had I sketched it from the top down or modeled it in any kind of intuitive way, but I started here from this XY plane, made a rectangular bracket, and then the majority of that was actually finishing features or detailed features like holes through the side on the top, on the flanges, chamfering those flanges before anything, which made it way easier. It allowed me to start with that rectangular shape in the first place, and then the addition of those holes. Thank you. So this is the most difficult part that I had to model. Number one, it's just kind of an irregular geometry. And number two, some of the dimensions that were provided for this particular part were not possible. A little bit of Pythagorean theorem and you can find out that it just can't possibly be that dimension. So after working through that, was able to get this part modeled. Still not the easiest though. I started from, similar to the last, I started from the YZ plane and sketched that out so I could pocket from a rectangular shape, a little subtractive manufacturing, got this overall shape, pocketed out the middle, and we were there. Moving on. This is the flywheel. This goes on the end of the crankshaft. Most interesting thing about this particular part is the differing thicknesses between the middle, the outside, and that center piece with the pin that will attach to the crankshaft. Having to transfer between the two of those was not incredibly simple, but starting with everything mirrored extent on a plane allowed me to just dimension half of each pad and make sure I was working in the middle of the part, and that made it far simpler. So this is the crank plate, second most difficult part I had to model. For two reasons. There is an M5 counterboard hole call out there. You can kind of see a little bit of that flange. Yeah, this part on the top, this little pad, holds the eccentric, and you'll see that. Ryan will talk about it here in a moment. The crankshaft runs through the middle, and then it holds the eccentric, and what that does is it allows the valve to move up and down with respect to the piston. It's just an incredibly irregular geometry. The most difficult part of it was dimensioned by radius and offset. So I had to use construction lines, but in the end we got there. And someone had to get the easy part. I was lucky enough to get this one. Circle, circle, pad. So this is a valve. Most interesting thing about this particular part is there's actually a hole that runs up through the middle, which makes sense in the actual assembly. There needs to be some kind of escape for the high pressure steam or whatever that this particular engine uses, and this valve at maximum height will allow that steam to escape from the piston and out. And here's the actual piston head itself. Similar drawing technique to the last one, two circles, two pads, and then I'll pocket out that square piece and add that pin so that we can constrain it in our assembly design to the bearing arms.
I'll take over at this point.
Yep, and I'll handle the clicking.
Alright. Alright, so this is the wooden base, pretty much really self-explanatory. Sketch and then pad on the XY axis and then chamfer afterwards. Next. This will be a 4-part series, given like this variant is made out of 4 parts. For this one, it was again pretty simple: 2 circles, 2 circles extrude, and then 2 holes. The next 2 parts are pretty much identical. It was a mistake on my part because I don't need to do modeling two same things at the same time. But here we go. It was the same thing, basically extruding this circle and then doing the chamfer for the edges. And like I said, this is pretty much the same procedure. And for this part, this was definitely more challenging than the previous things. For what I recall, I modeled this on the YZ, the circle on the YZ, the smaller circle first, and then just basically padded it, and then added the larger circle on the YZ axis as well, and padded the same thing. Okay, for this cylinder, it was a cylinder padded out, and then adding basically a chamfer on the Y and Z axis to create this part. Alright, this is the crankshaft. The difficulty for this part was to think which portion should I create first. So I created actually the big end first by basically drawing a circle and then just extruding it, and then adding the smaller portion to the end before extruding and pocketing that inside, because there's actually a pocket in this area. And last but not least, I put a whole command through here to create the area where I think is an empty circle. I can't accept my memory. Alright, this is the crank pin. Well, this is the simplest thing in this project, let's be honest. It was sketcher, extrude, and then a hole in here. Alright, this is the eccentric, and this is probably the most difficult part I've handled in this project. It was a circle to extrude, and then if I recall, I made the whole command in here first for, I think it was an M5 circle, but likewise can't remember the specifications. Last but not least, I also made a through hole command here as well for, it was a rectangular through hole. This is the valve con rod. If I remember, in this assembly, it was inside this design, not the ones on the external. How I modeled this was to go through the Y and Z axis with the circle here, and then after that I created this part, I padded this and then padded this, and then just made 2 holes to create this. Last but not least, the piston con rod. It was this portion here. It was basically creating the rod with the reference center line added there, just to make sure both were symmetrical, and then 2 holes.
Alright, so sorry for the switch there. I'm going to take over real quick just to talk about the assembly design. So these are the drafts we had to do. Looks like I might have misplaced my isometric model, but it was in the beginning, and I did point that out. So if you need to, you can refer back to that. Also, there's a nice drawing here. So actually constraining the assembly design, most used tool, probably almost the only used tool in constraining this assembly, was concentricity. All of these parts are relative to some kind of hole or shaft or some circular design. So making them coincidence puts those axes in the same line, which makes it very easy, and then you can just coincidence the flat spots of each part, put them next to each other, or offset otherwise, but the majority of this part was just made by so many coincidence constraints. And you can kind of get a sense for that when you look through, start with the flywheel, and then all those parts we just talked about are along the crankshaft, except for the con rod and piston rod, which go up, and they're still concentric with the holes in the piston cylinder. So lots of coincidence and concentricity constraints. Going through the drafting process, I'm going to pass it off to Ryan because he did such a phenomenal job with this exploded view and parts list.
Alright, for the drafting, what I basically did was just move parts all over the place until I could see each part without them overlapping each other, and then just basically placing numbers on with alongside of this list to see which part represents which shape in this diagram. And for materials, I couldn't really find any reference to what sort of material was used to build this other than wood for these two parts. So that's the only material we put up there.
I apologize. It looks like you guys probably can't see much of that exploded view. There it is. Now you can. Okay. So get a good look at that. And when the webcam comes back,
in our presentations.
Okay.
Thank you very much.
yeah, thank you guys for watching. Overall, this project was interesting, a little labor intensive, but definitely fulfilling to see the assembly come to the full assembly design come together and look so much so similar to the drafts that we were given. So, thank you again.